Hello, my dear friends. Welcome to Math with Amala. Here we start the first chapter of Grade 7 Maths Integers. There are 7 sections in this chapter. First one is Introduction to Integers, Properties of Addition and Subtraction, Multiplication of Integers, Properties of Multiplication, Division of Integers, Properties of Division of Integers, and the last exercise 1.1, 1.2, 1.3 in detail. So while we are dealing with the properties of these integers, first thing that you have to keep in mind is the closure property, then the commutative property, then associative property, and the last one distributive property. Along with this, you will have something extra, which are the additive identity, multiplicative identity, and so on. So let's discuss each point one by one without any delay. What do I mean by integers? What are integers? Integers are actually a combination of some numbers, and I have written here what are n natural numbers, w whole numbers, and for z integers. So in the circles you can see that in that oval shapes you can see that what are those numbers. 1, 2, 3, 4 are natural numbers. 0, 1, 2, 3, 4 etc. are whole numbers, and the numbers which are including the negative numbers also together in it along with whole numbers is called integers. That is, if 1 comes, minus 1 also will come. If 1000 comes, minus 1000 also will come. Likewise 0 also will be there in that combination of set. Next, what are the properties of addition and subtraction of integers? When we have this kind of integers, we have to operate something in it. So the first property is closure property. Closure means, like the name indicates, it is closed. Closed means it should be inside, like it should be belonging to that integers only. Let us take minus 1 plus 3, that is addition of integers, that is 2. Actually 2 is also in the integer set. Okay, so it is belonging to, or we can say contained in integer set. Next one is closure under subtraction. Likewise, what we have done for the addition, we have for the subtraction also. So let's take an example. Minus 1 minus 3, that is minus 4, that is belonging to z. Minus 4 is also in the z, that means it is in the integer set. Minus 4 is an integer. Hence, it is closed under subtraction. Without any doubt, we can say it is closed under subtraction. Closure property closed under. Closure property closed under. Okay. Next, commutative property. What is commutative property? Just reversing what you have taken. If you have taken a plus b, then take its reverse, b plus a. So I have given here like a minus b is not equal to b minus a, but a plus b is equal to b plus a. Let's take 3 plus 2, that is equal to 2 plus 3, it is obvious. But in case of 3 minus 2, 2 minus 3, they are not equal. So we can say only commutative property is holding under addition for integers. So integers are commutative under addition only. Okay. Next is associative property. What is association? Yes, just associating the brackets. A plus b plus c equal to a plus b plus c, and we are just associating the brackets. That means we just make an arrangement in the order of operation. In the first case, b plus b is done first. In the second case, a plus b is done first. So let's take the LHS and RHS. In both cases, we are getting 4. 3 plus minus 1 plus 2 is equal to 3 plus minus 1 plus 2. Hence, in the both cases, we are getting LHS and RHS are equal. Okay. So, if we have negative or subtraction instead of addition, it is not possible. Let's see. A minus b minus c is not equal to a minus b minus c. So, the proof is given with an example. Let us take 3 integers and just subtract them using associative property. 3 minus minus 1 minus 2. So the minus 1 minus 2 bracket will be done first, that is minus 3. So 3 minus 3 is equal to 0. This is the LHS. Now let's do the RHS. 3 minus minus 1 minus 2. So 3 minus minus 1 is 4. 4 minus 2 is 2. So LHS is not equal to RHS. 0 and 2 are not equal. So this is not possible. That is, associative property is not possible for subtraction. Next, E part is additive identity. Here, A plus some number equal to A means obviously it is 0 only. 0 plus A equal to A. A plus 0 equal to 0 plus A equal to A. Hence, we can say that 0 is the additive identity of integers. Next topic, multiplication of integers. How you will multiply? With some positive or negative integers. That is the property that we are going to deal here. Let us recall what is Z. 0 plus or minus 1 plus or minus 2 plus or minus 3. So my question is whether minus 100 is an integer? Yes or no? You can just comment minus 100 is an integer or not. Okay, so multiplication of positive and negative. That means we are giving two different cases together. Positive and negative integers multiplied together. A into minus B equal to minus A into B. That is just rearranging the negative sign. And you will get the same. Minus of A into B. So 3 into minus 11 is equal to minus 3 into 11 means it is minus of 3 into 11. So wherever you have the negative, it is same for multiplication. It is taken for both. Okay. Next, multiplication of two negative numbers. Let us take two different negative numbers. Both are negative, minus A and minus B, which is equal to positive A into B. An example is given there. Next part is properties of multiplication of integers. So the first one, as we have discussed for addition and subtraction, it is closure property. A into B. If we take any two integers and multiply them, so it is again an integer. Let's see. Let's take a minus 1 into minus 20. That is again minus into minus is positive. So 20, this is an integer. Hence, integers are closed under multiplication. Next is commutativity. Means we have to take two numbers and reverse under this operation multiplication. Okay, so let's take A into B. A into B means it is equal to B into A. That is called commutativity. In the addition, we were using A plus B is equal to B plus A. Let's take an example, minus 1 into 4, which is equal to minus 4. 4 into minus 1, which is equal to minus 4. Both are equal. So LHS and RHS are equal. Hence, integers are commutative under multiplication. Next, multiplication by 0. Multiplication, you can take any number and multiply it with 0 means it's always 0. Whatever be the number, whether it is a natural, whole number, integer, whatever number, it is again a 0. So let's take a 2 into 0, which is again 0, that is equal to 0 into 2. Let's correct it like 0 into 2. D part is multiplicative identity. Multiplicative identity. What do you mean by this? As we have discussed for additive identity. What was additive identity? A plus 0 is equal to A is equal to 0 plus A. Whatever be the number we are adding with it, adding with the identity, you will get the same number. Likewise, whatever be the number we are multiplying with it, you will get the same number. So A into 1 is equal to A equal to 1 into A. Only 1 is maintaining the number as it is after multiplication. So 20 into 1 is equal to 20 is equal to 1 into 20. In both ways, both are giving the result 20, giving the result A. Okay. Next is associativity of multiplication. So how we can do this? Yes, let's take three numbers instead of 2 or 1. Let's take 3. Just write it A into B into C equal to A into B into C. Both are same. But association is coming in the bracketing. So in the first case, you will have A into B is A into B will be done first. Then the next case B into C will be done first, and then the next procedure will be done. So 8 into minus 2 into 3 equal to 8 into minus 2 into 3. So you have to take care of the stressing. A into B into C equal to A into B into C. Okay, in both case I have shown here LHS and RHS are same for the example. Next one, F part is distributive property. As the name indicates, this is just distribution. This is just distributing multiplication over addition. We are giving multiplication along with addition. Okay, so let us take three numbers again. What are three numbers? A, B and C. They are integers again, and we are giving it like A into B plus C. Multiplication is distributed. So A is multiplied with B and A is multiplied with C, and they are added. Then after that they are added. So A into B minus C also will give the same result with a negative at the center. A into B minus A into C. Okay. So let's take an example for the first addition, multiplication over addition. The second is multiplication over subtraction. So the first one example, 3 into 1 plus minus 2. 3, 1, minus 2 are integers. So let's do the LHS and RHS separately. In both cases, we are getting minus 3. So LHS equal to RHS, that means a distributive property of multiplication over addition is holding for integers. The last topic is division. So division of integers, how will you divide? The only condition that we have to bear in mind is that the denominator should not be 0, because division by 0 is not defined. Okay, so the first part is A divided by minus B, that is positive number divided by negative number. That is, it is the same as negative number divided by positive number. 3 divided by minus 2, 3 by minus 2, minus 3 by 2, same as minus 3 divided by 2, minus 3 by 2. But you can note that minus 3 by 2 is not an integer, it is something else. Okay, then the B part is minus A by minus B, that is both are negative. Both the numbers are negative. So let's write it like A divided by B. Why? These negatives are getting cancelled, where B not equal to 0. So A divided by B. Let's take an example of minus 2 divided by minus 3, which is equal to minus 2 by minus 3. Let's cancel the negatives because both numerator and denominator contains negative. Answer is 2 by 3. So it is very clear that 2 by 3 is not an integer. So we can say it is not closed. Division is not closed. Okay, that is integers are not closed under division. Okay. Next, the last property is last topic is properties of division of integers. So the first property is A divided by 1. Any number divided by 1 is that number itself, and division by 0 is not possible since division by 0 is not defined. So whatever be the numerator, the denominator should not be 0, but the numerator can be 0. Okay, thank you all. Thanks for watching. Stay tuned for part 2 for exercise problems.